Hi, good morning, everybody. My name is David Bonifacic, and I'm the CEO of WB. A year ago, we hosted a webinar about repositioning office buildings to labs. We're here today to talk about what we have seen, and what has changed in our lab projects since then. What definitely hasn't changed is the demand. We have never seen demand like this in the 12 years that we've been in the life science market. Since this is a national audience, we are not going to talk specifics about any design requirements specific to cities and states, but please ask the questions. Now, it is my pleasure to introduce you to one of our top experts in lab design and life sciences, Ray Doyle. He leads our life science practice and is based out of our Raleigh office. Please ask your questions in the Q&A. We'll answer them as we go along or at the end. And at 10 minutes before the end, we'll unmute everyone if you'd like to ask questions verbally. Ray, take it away.
Thank you, Dave. Appreciate the introduction. For those of you that are interested in getting AIA credits as part of this presentation, we have to provide a few slides for you folks, and there's a survey at the end with a link to those requirements. Learning objectives will be covered and also defined in the final webinar that will be posted on our YouTube channel. So let's start with the big market changes. As Dave said, we did do this about a year ago, and there's a lot that's changed. The biggest thing is that most of the easily convertible buildings are off the market. Demand quickly gobbled those up. We'll talk a little bit about that. We'll talk about how locations are driving, the fact that the easily convertible and nice locations are kind of gobbled up. And we're talking about how locations are more remote and how we need to deal with that. The kind of complexity of flex warehouse space and how that's really jumped into this discussion of conversion and ability to provide more quick conversions to meet the demand. The opportunities, are changing for different reasons. We'll talk about some of that as well. So just kind of baseline stuff. We talk about lab types, we talk about manufacturing, we talk about chemistry, we talk about clean rooms, talk about biology and electronic rooms, but as somewhat specifically to life sciences and the demand that's driving a lot of the need for these conversions, we're talking about manufacturing space and biology space. A lot of those include clean room space, and then on the edges you'll see, electronics labs and chemistry labs that'll support some of the R&D that goes into some of the manufacturing. Knowing that life science product types are not all directly related to biology, even by definition, life sciences is biology. The market sector drives some of these other labs and brings them into the discussion. So we'll see a lot of these different conversions and need for space across a few different lab types. One thing that is still not changed is extremely important that you pre-plan to optimize your flexibility. And I would argue more today than even before. As you look to convert buildings, you're finding less available buildings on the market. You're finding less buildings with larger floor-to-floors. You're finding less buildings in locations that are desirable for employees. So you really need to start looking at ways to define those opportunities for employees and landlords and clients. So defining that maximized flexibility is what's going to help promote buildings in a given location. The key thing here to remember is that what tenants care about. If you're a landlord, you're trying to figure out what they care about and and how to provide it. So as you master plan your solutions, you need to talk through the flexibility, the adaptability, the adjustability, and the expandability that as a landlord, you're going to try and provide to your lab tenants. The lab tenants really want to make sure that they can have all of that at a reasonable price. And that's where you got to meet in the middle. But the important thing is to understand that both parties are interested in all four of those topics and meet in the middle as you negotiate space and find ways to reposition buildings. This is one of my favorite descriptions of the problem. clients, tenants, life science companies are in this category of the lab tenant. They're a little bit on the left side, and they think with a PhD mind, very scientific, very driven towards the solution to help save society from things like COVID and other diseases that plague us across the planet. But the thing that we need to do as an industry is kind of figure out how to get the design professionals, the landlords, and developers to get to a common ground, common language, a way to discuss these topics so that we can have people occupying buildings in a successful way and in a functional way so that they can get that flexibility and adaptability that they really need. Not that they want, but that they really need, because sometimes you can't have it all. So architectural criteria, some of the big things we want to talk about is how understanding what it means to have a utility matrix. A utility matrix is something, or excuse me, not utility matrix, responsibility matrix, helps you define who's going to provide what. So in the case of a simple thing like an elevator, is there a freight elevator or a service elevator in the building already? Are you going to need to add it? Is the landlord paying for that? Are they going to provide it? Is there a loading dock in the building? Are they going to add one? So there's some big elements that need to be addressed before you even get started to decide how convertible a building can be. And those are usually at the top of my list. Everybody tends to understand pretty clearly the basic elements of a building, whether it's an office building or a warehouse. But most people think of the place that they work in terms of an office and how they can easily relate to that, whether you're an architect or developer or a landlord or a broker. You understand that world really clear. What's not so clear is how broad the differences can be in a life science building. When you start talking about chemistry and vivariums and cryogenic liquids, the differences between R&D and manufacturing, and the differences between medical devices and vaccine manufacturing. And I said as a minute ago, bare minimum is you have to have a loading dock and a service elevator for these types of life science conversions. One of the other things that will be probably the most critical is evaluation of the building height. If you're going to convert a space from an office or a warehouse or a flex warehouse to a lab or a manufacturing facility, you need to understand the impact of that height and understand, based on your master plan, how you're going to be able to accommodate a possible tenant. So in an office building, you're typically going to have one duct system. You're going to run a ceiling plumbing, and you're going to have a centralized set of core elements like plumbing risers and electrical risers. I think the interesting thing is to remember is when you think about these buildings, they were, at the time they were built for a purpose. So they were not built with the ultimate flexibility. They were built with a purpose for what they were intended to be used for. So when we think about the impact, we think about, how much space do we really have to move ductwork and utilities through the ceiling cavity? Then we have to understand, do they need to be serviced from above, or do they need to be serviced from the ceiling below? So the constraints could be, could be 2 or 3 or 4 duct systems. You could have supply, you could have a return exhaust, you could have a general exhaust, you could also have a specialty exhaust in that system. So you could end up with 4 or 5 duct systems, and you could see how even with 4 feet, if you have to cross 2 or 3 of those duct systems, you're really going to run into challenges with coordination and the ability to construct and the ability to service and maintain all of those devices. The decentralized plumbing systems will be required to make the conversion work. So if you're used to seeing all of the plumbing risers in the central core, you're typically going to need to have them at the thirds or the quadrants to make sure that you can get the laterals out to the sinks and out to the various, whether it's manufacturing or R&D equipment. Lighting is always a concern, and you need to make sure you keep that clear and you maintain your sprinklers and your lighting profiles in your ceiling plumbing so that it doesn't interact with your duct systems. The warehouse solution is something that's really, I think, based on the demand, and the fact that most of it's been gobbled up, A lot of warehouses are now becoming targets. And one of the reasons they're a target is they're easy to convert. There's a lot of it available, or at least in most locations around the country, there's a lot of it available. And it has a lot of space, so it kind of makes it a nice target for conversion. A couple of things you really need to think about when you start talking about building heights and warehouses. You need to understand, are you looking at, and there's a section here that shows, 24 to 26 foot clear height. And that'll get you a mezzanine or, walkable space, maybe on top, or a manufacturing space. But you're probably going to need in excess of 24, maybe 30, 35, or 40 feet of height if you really want to get 2 levels of occupied space, whether you want to put office or storage or a mezzanine above the space that doesn't require access. Maintaining a clear space above the manufacturing spaces or some of the lab spaces, definitely the clean room spaces. You want to be able to maintain that, all of those systems from the mezzanine above. Mechanical systems, that similar, the criteria today is even more, apologize, I'm having a couple internet issues, but the criteria on the mechanical side is very simple in most buildings. And because they're purpose built, like I was saying, relative to office buildings earlier, the idea is they're very code driven. You just need to provide a code ventilation. You need to meet the heat loss and heat gain to provide an occupied space. When you start talking about mechanical systems to support labs and manufacturing areas, you start getting into a lot heavier mechanical system requirements, and they dramatically can impact the physical space. If you start talking about, the specialty heat gain equipment, you start talking about air changes, 100% outside air systems, energy recovery, where are you putting that? Is that in a mechanical space? Is that in a leased mechanical space? Or is that in, a penthouse or a roof space? So you get into very quickly a lot more building footprint requirements when you start talking about lab system mechanical infrastructure. So some key concepts to think about, and understanding how they impact your conversion is what's important, because every tenant doesn't require the same HVAC solution or electrical or plumbing solution. So what's important is understanding the concepts and then knowing how to apply them. And I always say that when we talk about, these master plans for your building, you want to make sure you implement these concepts. And sometimes you would have a master plan A and a master plan B so that you could maybe incorporate both of these concepts in a test fit or an engineering concept design that would allow people to see how your building would actually function in the future once they moved in. Some cases you may build that. We'll talk about that a little bit later. 100% outside air, it couldn't get much easier in definition, because 100% of the air that goes through the air handling unit system goes into the labs and then is exhausted out of the building. The reason this is on the docket is to make sure that people understand the difference between 100% outside air and single pass air. And it's really important because they get used interchangeably, and it's important to understand why they're different. In the case of a single pass air system, you are mixing the return air and the outside air from spaces like offices and some lab spaces that don't have exhaust requirements or low toxic level or low biology level labs. And then you're mixing that at the air handling unit, sending it to the lab on the right. And that lab is what we would call a single pass air lab. And it goes in one time and directly out of the building. The one thing I like to point out when we talk about this slide, when you start talking about conversions, you need to understand, if you're going to take the approach of a single pass air solution design, at least from a conceptual standpoint or from a spec lab standpoint, if you're going to build your spec lab with this strategy, and it's a reasonable strategy, it's a lower energy, lower first cost strategy, it sometimes will limit the type of tenant that's interested in your building. Because if you have a bioburden concern, or you're worried about any biologics floating from one space to another, you are subject to a problem when they mix at the air handling unit and potentially take live bacteria or cells from the office or lab area on the left and mix them back and send them to the lab on the right. So the challenges you have there is understanding in your building master plan the limitations of the mechanical system that you may suggest or you may provide as a concept to your tenant. Again, back to the idea of possibly having two concepts for your HVAC strategy in your conversion so that the potential tenants that want to look at your building have options and they don't see you as a roadblock to their ability to rent your space. They see you as an opportunity because you have an option to do both. Keep that flexibility open and drive the potential for people to occupy or lease your building. 2 to 3 story buildings, I call them the low rise. We're kind of comparing those to a 3 and up story, a 3 and up number of levels building. And the reason we provide this again is so that when you do your concept planning and master planning, you can show designs to the potential tenants so they see how they can have their own rooftop unit if they're in a 1 to 2 story building. They can have their own exhaust fans. They can have all of their own infrastructure. They can manage it, maintain it, control it. They're not at the mercy of potentially the landlord or another tenant to have a problem that could impact their science. So it makes it a nice opportunity with a lot of benefits to potential tenants. In comparison to that, you have a 3 story and up building where you're going to find yourself needing to evaluate the physical space on the roof. Straight away, how much space do I have? I need to figure out a master plan concept that allows me in my conversion, whether it's a warehouse or an office building, the ability to create a concept design for modular systems so that you can have modular chillers, you can have modular air handling units, and you can have modular exhaust fans. And the reason you really want to think about those components is those are the biggest components that are going to occupy space. But if you do it in a systematic way, you can add an air handling unit and a chiller or an air handling unit and an exhaust fan per floor and buy them as you lease your buildings up. And then they would have a shared system with reliability and or redundancy. You can look at both strategies. The key there, sure you understand where to locate the shafts, and we'll talk about that in a few minutes as well. Electrical systems, I think the key here again is code-driven minimums. When you start talking about most buildings, they were purpose-built. They were not built for the ultimate flexible conversion to lab or manufacturing. So we find ourselves looking at buildings in most cases, for light conversion to lab. You might find a building that's 20, 25, 30 years old that has enough power for a light conversion, where you have lower density labs. But if you get into a conversion where you have a 70% lab, 30% office, you may be looking at power upgrades. So the first thing you want to study is your ratio of conversion, lab to office, understand how much power you need, understand where those upgrades are going to be required and how those need to be added as you talk to the utilities. You might be able to partially occupy a building as you lease it up with the original power service and then add or heavy up the service after you've started your leasing. So there's multiple ways to deliver a building, knowing that being online as fast as possible in this market is critical. So you need to look at your opportunity there to start with the power you have and then look at a heavy up. The other thing you need to make sure that you're looking at, when you talk about tenants, and some of these will be provided by the tenant themselves, UPS power systems will be provided by the tenant. Sometimes your lab standby power generators are provided by the landlord. Sometimes they're provided per tenant. That's something you need to design into your master plan and make sure that, if you're going to take an approach, you kind of stand by that approach, because it's going to be one that's going to start to occupy space either on your roof or in your parking or in the adjacent green space when you start talking about generators, and then how you're going to run those bus or feeders up through the building to accommodate the multiple options. Dual power systems probably aren't going to come into play too much in R&D, but you may see that in your manufacturing facilities, which are really driving some of this flex warehouse space right now, and their demand to produce those, whether it's medical devices or or vaccines or drugs, they need to have a very robust system. And it's nice sometimes to have that dual power system. Lighting power density is just going to drive your power service up. Typical foot candle levels are anywhere from 4 to 5 times what you'd have in an office building. So you're demanding more power and more lighting levels. Plumbing systems. I think, again, you talk about purpose-built buildings, we look at, the basics, sanitary, domestic water, natural gas, which in some cases is getting eliminated by some areas where they're greening the grid and looking to do all electric, but which will drive you back to the page before. If you're really going to look at greening the grid and getting rid of your gas systems, natural gas systems, you're going to be looking at even more power requirements. So understand that when you look at your locations. Similar way to the HVAC side, there's a lot of extra systems and risers you need to manage through. Is it between tempered water for emergency showers, RO water, lab waste, bio waste, compressed air and cylinders? There's a number of gases. You could do bulk gases and you could do cylinder gases. The one thing I like to say in your master plan, and we talked about that responsibility matrix earlier, you need to start defining what you're going to provide as a landlord. And as a tenant, you need to look towards what is the landlord, what are you expecting from the landlord? Are you expecting, let's just say, for example, a pre-treatment water skid where you're going to have, particulate filter and softener, and you're going to have tenant by tenant water treatment for RO or DI or USP or Wi-Fi, whatever you might need. And that will drive, the strategy for leasing. It'll drive the strategy for physical space and how you want to lease it and how much space you'll need to lease. In a similar way, you start looking at things like cryogenic liquids. They bring additional requirements. Not to mention they're very costly, but you might have bulk tanks outside. You might run those with dewars, but you may also then have to deal with additional safety concerns, the life safety issues that come with cryogenic liquids.
If we could just take a moment along those lines, we have questions about chemical storage on a 4+ building. Before you, can you touch on that one?
No, not a problem at all. I'm gonna go through a separation on duct systems in a few minutes, but the real important part of, I think, the question, and I'm not gonna say I'm gonna get to the root of it. So ask me again at the end if I don't answer your question. The important thing to understand is that as you go up in a building, the life safety and IBC code will limit the amount of toxic chemicals and flammables that you can store in a building. And it's kind of logical. As you go up in the building, you want to limit the amount of hazard that you have so that the firefighters can go take care of the people that might be in those upper floors. You can increase the amount of toxic chemicals or flammables by defining something called a control zone, which is an additional rated enclosure on each floor. And the number of rated enclosures, is somewhat limited by the code. I don't want to get into the details of that specifically, but we can definitely get back to whoever asked that question relative to a specific example after the presentation, because there's some details you need to get into. So hopefully I covered the general answer to that question.
Right. And then Ray, one other question along with MEP was the extended lead times we're seeing right now in the industry. Go ahead.
No, that's great. I think the importance of, it really comes down to your master plan too. I'll go back to that initial thought, because we really need to understand when you start thinking about buildings, how much of that equipment needs to be bought up front, maybe prior to tenants coming in. So the idea of a spec suite is driving people towards buying equipment and then building it and then leasing it after they've built it. If you find yourself needing to be, say, for example, I'll use an example from a project we did not too long ago. We had a dry storage room for manufacturing specialty device, and the dehumidification equipment to maintain 20% RH year round had a year plus lead time. And that particular tenant actually had a contract requirement to deliver products that are built in that room before that year plus deadline. So there were some temporary solutions that had to be figured out, and we had to do some innovative things to get them in a place where we think they can get to a manufacturing state earlier than a year plus. So casework's a year plus, HVAC is 20, you look at rooftop units, you're looking at 20 to 40 weeks, depending on if it's custom or semi-custom or, standard rooftop equipment now. All of this is obviously driven by COVID and the supply chain limitations, but we're trying to navigate through that. And again, planning early, getting the design professionals and the contractors on board early to look at, pre-purchase and understanding the long leads that are critical to your build, obviously will help you get through it. So the master plan isn't just the building programming, it's the infrastructure, it's the master plan of construction and the constructability aspect of being able to build it. So I always say that master plan is more than just the program itself. So we talked a little bit about cost. I think the interesting thing that's changed over the last couple of years is, we talked about, most people can reference office buildings pretty clearly in their head, and a core and shell is still a reasonably priced building when you talk about a 40 to 100,000 square foot office building, in that range of $200 a square foot, 180 to 215. The interiors fit outs that's gone up a little bit, mostly because of the supply chain and inflation and the cost. We look at the core and shell for a lab. It's gone up a little bit as well. Basically, supply chain and inflation have driven that up a little bit, but you're still in the range of $250 to $500, depending on your finishes and details and things like that, and how much infrastructure you're really going to buy. But the warehouse space, it's quick to market and inexpensive. So even if it's not available on the market today, throwing a tilt-up warehouse together and getting something to market quickly, you could see how there's an advantage to at least considering the warehouse option. The fit outs itself, they're going to be about the same as what it would cost you to fit out, a typical lab building if you're going to do an R&D building with a nicer facade and building location. So the real estate relative pricing is something that I like to talk about, and everybody has an opinion on this, but my personal opinion is most people that are building office space, they want to be in kind of this work-live play kind of area, little mixed use areas, and that real estate's going to be a lot more expensive than you would typically find. So if you were converting one of those spaces in those mixed use areas, you're going to spend a little more money, and it's relative, but you're going to spend a little more money for that real estate regardless of where it is around the country. The idea of lab space, if you were looking at converting something in the suburbs that maybe isn't directly related to that work-live play area, but it might be kind of mixed use zoning, you're going to find yourself spending a little less. And then as you go the other direction, you're going to spend even less money to find warehouse space. It's a little more on the backside of the towns, a little more in the industrial areas. But again, quick dollars to build one, short money to buy the real estate in typical case. And then you can build the space out inside as nice as you'd like, and kind of from the inside out, you have a really nice space. And when you talk about manufacturing, there's not a lot of manufacturing spaces with a lot of windows. They do have windows when they can put them in, but it's not a hard requirement. So having a really nice view to a lake or a mixed use neighborhood isn't a high priority for most manufacturing companies.
So Ray, along these lines, we have a question. Does that mean a completely new lab build out is about $1,100 a foot?
Yeah, so if you were going to build one brand new, you'd see $1,100 a square foot. It's pretty extreme when you start thinking about the cost of building out a nice lab space. And it varies as the scale and the ranges here define. If you're talking about a simple R&D bio level 1 lab space, you can get away a little cheaper. You start getting into a mix of light manufacturing or a pilot plant, those numbers can go even up from there. You could see it, in a $1,500 a square foot. So it depends on the details, but it just kind of gives you a ballpark range on what's going on in the market. And the other thing I want to point out here is I talk about is, and for the contractors on the call that are part of this, they know that their subs, their providers, their equipment, Their material providers, they're not holding prices right now. They're all scared of inflation, and anything that happens relative to that could drive these prices up from today. Some people are seeing as high as 10% increases a month, and that's pretty extreme. So again, back to the get to market quick solution is going to be a way to try and save some money, at least in the market we're in. So always be paying attention to that, the market based on materials and inflation, because I think that's going to be another huge driver that we can't ignore. We're going to have to keep our finger on the pulse of, both on the design, building, and development side. And if tenants need to get in quick so they can beat other people to market, all of those things are going to be drivers. So we went through a little case study here, and what I want to share is this idea of a building that's, a typical building with 30,000 square foot floor plate, 50% office, 50% lab. And think about the office space, and these are just general loads for space, sensible heat gain or space loads in an office space. So we just blanked it out at 1 CFM a square foot. We also assumed in this particular example, 1,000 CFM of lab exhaust per 1,000 square feet. So that just gives you a pretty straightforward ratio of comparison. And the thing that it's important, and we talk about master planning buildings, and we talk about how there's more buildings available with tighter floor to floors. So I wanted to give you guys a comparison between an all airside solution and a waterside solution. And I'll start with the top at the idea that if you have 50% lab and an airside, you're going to need roughly 2 CFM a square foot to do an airside. Now that airside solution at 2 CFM a square foot is going to provide roughly 1 CFM a square foot of 100% outside air makeup to support the lab exhaust requirement. The additional 1 CFM a square foot would be provided for the sensible cooling needs of that space. And the interesting thing about that, when you start talking about the sensible heat gain of 1 CFM a square foot over 30,000 square feet, it's 30,000 CFM, depending on the velocity you want to choose, you could be looking at a 50 by 50 inch by 50 inch duct, which is not insignificant in terms of riser, one, and for distribution on the floor too. So that's the airside baseline that maybe would have been used in a lot of cases by pharma and conversions in the past. The other side of this is you take the waterside comparison approach, and you have the same thing at the top, but instead of having the 2 CFM a square foot for the 50% lab, you'd have 1 CFM a square foot, with that 1 CFM a square foot being provided strictly to make up the lab exhaust requirement. From there, you would provide the other half, which would have been 1 CFM a square foot for sensible cooling. You look at it from a chilled water standpoint, and there are DX refrigerant strategies that could be even smaller, but let's just stay on the water side discussion for a second. For 30,000 square feet, you're going to need 100 GPM of chilled water. And again, you can change your delta T, but just nominally say it's 100 GPM. So in terms of space comparison, for air, you need a 50 by 50 duct. For water, you need to get that energy up and down through the building, you need a 3 to 4 inch pipe. Pretty significant difference. The one piece that you need to add on the water side solution is whether you use DOAS VAV, where you'd use VAV boxes with cooling coils, or you can go to a 4-pipe fan coil solution. You could also look at small air handlers. In the right application, you could even bring in chill beams. And that would be for control of individual space temperature control. So you can see how that space is pretty important.
Right. Along those lines, then, when you're sizing that lab, there was a question on the electrical side. What's the strategy sizing a generator for a lab? Give an idea maybe of watts per square foot.
Yeah, so on the energy side per square foot, you're going to be looking in your master plan. Let me back step. In the master plan, you really want to make sure on the electrical side that you have a strategy. So in that utility matrix or responsibility matrix we talked about, you want to define how many watts per square foot of emergency generator power you want to create, standby power. That could be anywhere from 50% of the total load to 100% of the total load. You could provide some of that as the landlord in that responsibility matrix, or you could defer it completely to the tenant requirement. Speed to market says you might want to consider having that as part of your base building systems that you design and install prior to finding your tenants. Because lead times on generators are driving some of these limitations to get people into spaces. So those are big considerations, but you could be looking at in watts per square foot anywhere between 15 to 100 watts a square foot. It can be pretty dramatic from the differences between low R&D requirements for standby power and 100% standby backup for manufacturing. Hopefully I addressed the question. Follow up at the end if there's an add-on there. So back to this comparison based on space and driving the idea that, you know, we want to get energy in and out of the building. We want to get the heat out of the building that's generated by the labs. If you can use a pipe in the Waterside solution versus the ducted Airside solution, you know, moving energy through a building is 100 times the area, you know, that's required by the pipe is 100 times less than it would be if you use the same energy in a duct. And this is important. The next thing I want to talk about a little bit is this again, available convertible buildings are getting limited, and people are looking to convert buildings that have a tighter floor to floor. And they can be done, but there's a little more upfront money that needs to be spent. And in my mind, a lot more planning or concept design development planning that needs to be done before you decide it's a feasible solution. So when you have a reasonable floor to floor, you just need to have your supply and potentially return risers, depending on how you're doing, either mixed single pass or 100% outside air in the central core. And then you could, on that top diagram, you can push those exhaust points to the external corners, so that, you know, when you come together with your ductwork, you're doing a little more of this, so that you can save floor to floor and manage large ducts without crossing and limiting the amount of bulkhead space you might need. When you get to a compressed floor to floor on the bottom, you could see how you could add an additional, with additional money and additional equipment, you could create a strategy where you can add additional cores. You could add an A and B core and centralize those, or you could add 3 cores with A, B, C cores, and then decentralize and make the exhaust ducts even smaller to feed each. Instead of each floor, you could do each zone or each half of a floor. And you could see how basically by doing that, you end up with smaller risers, which means smaller horizontal laterals coming out of the shafts. The real advantage of that, again, is with a tighter floor to floor, you're cutting the ducts in half or by 2/3 in some cases, and you can then reduce the amount of total floor to floor you need to convert to a lab space. Tight for flexibility and adaptability, but it is a doable and feasible solution. Making sure that you understand the cost associated with those and the space that you're going to give up for additional shaft space. So there's pros and cons, but it is a feasible strategy. So we talked a little bit about fire separation and the idea of having the exhaust separated in the diagram prior. But the important thing to understand is that a 2-hour rated enclosure for each fume hood exhaust system, hazardous exhaust system, that feeds each floor needs to be in a dedicated riser from the floor that it serves all the way to the penthouse or the roof. So in the diagram here to the right, you can see how that individual shafts with 2-hour rated separations would give you a duct from each floor to the roof or penthouse. A small alternative to that would be fire-rated risers. They make fire-rated duct. And that is a nice strategy, but also very expensive. When you master plan it, you need to understand the cost of that. Sorry, was there a question? I think I got a little background noise there. Sorry about that. If you could mute, that would be great. The alternative to that fire-rated duct, and in some jurisdictions, they allow you to, in fire-rated duct strategy, to use a subduct. You need to review that with your authority having jurisdiction to make sure that they allow you to do that for hazardous exhaust ducts. Some places they accept that. This is where it kind of gets nice. If we follow all these things and we start, building this vocabulary between, the tenants, the landlords, the design professionals, and we understand the needs of the lab tenants, and we understand the flexibility that they would like to have, and we start to understand some of the things about supply chain limitations right now, the limited availability of easily convertible space. We start to have a good conversation with tenants, with landlords and design professionals, so that we can position buildings for success with good master plans. And with good master plans, we can communicate those elements and their limitations to a lab tenant. So having 2 or 3 options in your master plan, and in some cases actually building out those lab spaces in the case of spec suites is highly desirable at this time. And the other thing we're finding in this communication between the lab tenants and the developers is that, we probably need to start stockpiling things like, if you have a Waterside solution and you're going to use VAV boxes, or you're going to use fan coil units, buy those, stockpile those, have them on site. So when you're ready to bring the tenant in, you can start to think about just simple construction, and you can have a straight timeline based on how long it takes to actually build it, as opposed to how long it takes to actually get the equipment there. So start thinking about those strategies to save yourselves the timeline issue. The key takeaway is the physical space, right? And we talk about all the way through this, the limitations, planning for flexibility, planning for options, makes that, physical space challenge a little less painful. The more you understand it, the better you can define how you can support potential tenants. That master planning consideration, some people are building the initial steps. They're building the infrastructure. They're putting in the chillers, putting in the air handling units, putting in the exhaust fans, or at least they're putting in the first module of a modular design strategy. They don't need to buy all the chillers, all the air handling units, all the pumps, all the fans, but you might want to consider the idea of buying the first or second module of each of those strategies and installing it so that you can get speed to market for your tenant. So it's a strategy you guys should be at least considering and looking at. And the pre-investment cost, record high inflation, and we know the supply chain's killing us all, and hurting our projects, and driving the need for a lot of pre-planning. But understanding those risk rewards of investing up front versus deferring to later. I put deferring to later because I think deferring to later might be a less than desirable strategy right now, but it still is a good strategy for some people that are looking to find tenants that don't have a really hard timeline to get in and build. So you got to position yourself in the right place for the market that you're pursuing, but understand that everybody else is probably driving really hard towards buying and pre-investing. We've heard from some folks they're buying all of the casework for 50% of their floors because they're just going to use those pieces of casework and have the architects plan around casework that's already purchased. Casework could be as long as a year right now. But if you have it in a warehouse and all you're doing is figuring out which pieces you want to put in what lab, even if you compromise on a few of the pieces of casework and you have drawers where you wanted doors, you can occupy the space and work around some of those things. So those are huge takeaways. There's a lot that needs to be figured out in every one of these projects, and the planning is really the most important piece. I can tell you is excuse me, that master plan is going to drive success. So with that, I'm going to finish about 45 minutes. So if you guys have more questions, or the ones that you did ask I didn't cover in the detail that you'd like, we can revisit some of those. The The QR code there is available for a quick survey, and for the folks that need the AIA credits, it'll run you through the process to get those as well. So first, let me say thank you for joining me. I really appreciate your time. I know everybody's busy and the market's really hot. So hopefully you got some takeaways that you can use on your projects and your collaborative efforts with your consultants to make your lives and your projects and your tenants more successful. Dave, I don't know if there's more questions in the chat.
Right now, no more questions in the chat. All right, we got one here. Can you expand about the chemical storage spatially for chemical storage seems to be a hot for taller buildings. Chemical storage seems to, I don't know if Andy's on, but maybe you can talk about it and some of the
so for
challenges.
Those of you who don't know Andy, Dave was referencing our internal code consultant, Andy Shanahan, who does similar webinars to this one on chemical storage, the limitations of how much you can store and on what floor and what containment you need to provide around it, whether it's toxic or flammable. And I think for that person who's asked that question, I'll make sure that I connect them to Andy, who's our professional within WB. I mean, there's others that do it as well in the industry, but having an internal resource is very nice. So I can connect you with him. But it really comes down to understanding the code limitations per floor, how many fire rated separations you need to have. And sometimes those fire rated separations don't always align with the architectural aesthetic that may be desired. So you need to be careful that you understand the amount of chemicals before you lay out your complete architectural strategy. I'm looking at the image on the screen. There's a lot of windows there. And putting windows in labs is perfectly okay. And you can do fire rated walls with curtains and all kinds of things like that, but they do cost a lot more money. And if you understand the fire separations based on the chemical storage requirement of the tenant, you can actually limit the impact and allow for the architect to have the flexibility to design those spaces to give you the visibility and vision glass that's desired while still maintaining the safety of the fire separations. The one thing that I'll add to that is making sure that if you're a speculative lab or you're a build-to-suit lab, it's important to understand the tenant's requirements. Sometimes just-in-time delivery of chemicals to the upper floors is fine, and you can put all the storage on the lower levels. When you design your spec lab building or you do a conversion, you need to consider having a life safety professional like Andy Shanahan, who works with WB, that can help you with your master plan so that you can think through the limitations of that building, whether it's fire separations or egress path from the stairs. There's a lot of things you need to work through, but understanding it up front before you start leasing it gives you a chance to understand your limitations.
And Ray, if we can also mention, we have a Hazmat in Labs on Demand webinar on our events page on our website. So if anybody wants to, Andy has done a similar webinar specific to hazardous materials and labs, and it's recorded on our website. So that's a good place to go.
So if they go to our website, they can get to the link to our YouTube channel and get to that webinar.
Right.
Yeah.
There's also a question, Ray, about talk about a little bit more about the cryo liquids. Any more comments on that?
Yeah, I think the liquid, nitrogen system is probably the most prevalent. There's other cryogenic liquids, but most people are dealing with liquid nitrogen, and the challenges are that if you're going to distribute it through the building, you end up with a very expensive horizontal and vertical distribution system, and that, is in vacuum jacketed piping. It's $1,000 a lineal foot. So there's a decision that needs to be made in your master plan when you start talking about cryogenic liquids as to whether you want to have dewars delivered, which are basically tanks with liquid nitrogen in them, and you deliver those to the points of use or lab spaces that need them, versus having a distribution system to each of those labs or each of those floors from a bulk tank outside. And there's a tipping point where, you know, if the tenant needs on demand and they don't want to wait for that dewar and it could impact their science or their manufacturing, whatever it might be, you need to start looking at how critical those things would drive a decision-making process.
Right, there was a continuation on the cost side of the number you quoted. Would this include FF&E, soft costs, and is this all in?
It is all in most cases. You could get into, when I say most equipment, casework, things like that, furniture. When you get into specialty scientific equipment, like fill lines and some of the manufacturing equipment, you got to be careful, because you could get into a lot of dollars per square foot. I mean, some of those pieces of equipment could double those values. So it depends specifically on if it's going to be a manufacturing building. That can drive those numbers a lot higher than the numbers on the screen that everybody saw.
Okay, and then there's a question about toxic exhaust. Is it filtered, or how do you make it safe to be released?
So in the toxic exhaust world, you end up in a couple of different categories. It could be toxic and flammable, or just toxic. If it's toxic and it's powders, we need to make sure that we filter those systems with HEPA. And a lot of times we would even add gas phase filtration downstream of the HEPA filters, bag in, bag out, stainless steel HEPA filters, so that you get 100% containment of that toxic chemical that's used in the fume hood or the process to save the environment itself before you exhaust that out through the stack on the roof. When you get into flammables, you could get into explosion panels, you could get into fire-rated ductwork with sprinklers in the duct, and then you get into very specific calculations based on the actual ratio of how much flammable gas is in the air to define those details. So it can get pretty extreme, Dave. But I think it's important to understand that once you get into those spaces, you need to start dissecting it at a much finer level of detail.
So Ray, it would be a summary. This is not something you can learn. How long have you been doing this now, Ray?
I've been doing it about 28 to 30 years. First couple of years, I kind of was in and out of it, but for the last 28, I've been doing technical life science buildings, and it takes a long time to get it all. And the other half of it, Dave, is I like to say I know it all, but I know I don't. But when you've done it 28 years, you know where you need to go to get answers to solve problems. There's a lot of code-driven issues, life safety issues, a lot of strategies for engineering solutions. So it does take a lot of experience and a lot of knowledge, and know who the partners are in the marketplace, the consultants, the right people to work with to create a successful project. So yeah, there's no substitute for having done it for a long time.
I think there's one here. There's a question here from Brian. What are the three most cities we've been, I'm going to read it verbatim. The benefit of WB being a national firm is that you have an overall view of the market in the United States. What are the three top cities, areas that are the most competitive that you've seen?
Competitive for different reasons, I think. I think right now, Raleigh, Boston, and San Francisco are the most competitive markets. And the interesting thing is there's a lot of other markets that drive that. There's cost of living, there's available technical staff coming out of the universities. which is one of the reasons that I think Boston and San Francisco and Raleigh have a good advantage. The ability to do work in other markets and understand the technical challenges of being in Denver or Austin or even Maryland, which are driving a lot of work in the Maryland area, are also important. But the interesting thing that you take away from it is understanding, and we said we weren't going to talk about specifics of cities, but if you understand Title 24 and you understand the limitations of the greening of the grid in certain areas of the country, you can start to understand the impact in terms of cost relative to areas of the country where they are still using natural gas. And you start to understand, where they're forcing life safety issues in one part of the country for a given reason, and that may drive future changes in code in other parts of the country, whether it's energy code or safety codes. Getting ahead of it is nice when you have as many locations as we do. It allows us to stay on top of the trends.
There's also one question I missed here, Ray. Do you recommend having wind studies to see where the exhaust is going?
And that's a really good comment as well. The conversions, most of the conversions are buildings that are a little more set apart. They're not in the mixed use areas because those buildings are not, there's not that many of them going up right now. But whenever you're in a part of a kind of a tighter urban area, you always want to do a wind wake study, because you want to make sure that you're not impacting not only yourself, your own intakes, which is a little bit easier to manage when you look at prevailing winds and things like the windrows that takes care of that. But when you get into buildings being adjacent to each other, you end up with up currents and down currents and wind currents that are impacted by the adjacent buildings that, without doing a wind wake, or at least a mathematical model of that wind wake, I'm not suggesting a wind tunnel test with models for every project, but there's a lot of companies that do a really good job doing mathematical models to understand how the air is going to move around a building and how it might impact the intakes. So for the complex or very tighter urban spaces, or tight campuses, even if they're in a more rural or suburb area, we're always recommending a wind wake study.
So there's another question right here. How close is lab HVAC, or is it close to what's likely going to be standard for IAQ in a one-story flex space?
I'm not sure I understood that question. Can you repeat it for me, Dave? I'm sorry.
Yeah, Harvey, if you can clarify a little bit on that one. I'll read the second part. Is there anything like bipolar ionization appears to be headed towards standardization across the board, an IAQ? And I guess this is an IAQ question.
Okay, so
yeah, I don't know if you guys can hear me at all. Can you hear me?
Yes, we can. Thank you, Harvey.
What I'm saying is that I understand a lot of the lab spaces in this area, at least, are going in one-story flex buildings and things like that. And you can obviously get much more improved conditions when you have access to the roof, and you can get more ventilation and everything else. And there's a lot of things that you're doing for labs that are in hospitals, hazmat situations like that. And you can really ramp these things up as they need to be to meet laboratory codes. But a lot of the same buildings now that are one-story flex buildings out there are also housing people, maybe light lab, maybe clinical things like that. What type of overlap is there right now? If I have a client that's looking for buildings that are not downtown, they're in more suburban or mixed areas that are one story, what type of HVAC is I guess would work? Not for both, because the laboratory is going to dictate those things, but what type of things are you seeing common across both areas, both type of markets, I guess, laboratory and people who are not quite that technical?
Okay, I think I understand your question. I'll take a shot at it, and then you let me know. But there are basically there's a lot of that 1-story, 2-story flex warehouse space around, and I think that they're really going to be driving a lot of the more the timeline sensitive projects in the future. So the HVAC solutions tend to be in the form of rooftop units. You can do 100% outside air rooftop units, and you can do minimum code with economizer rooftop units for the office space. And typically we would separate those so that the offices have a separate, because typically they also have a separate schedule. So your office staff may go home in the evenings, and you can shut down all those rooftop units when the weather and humidity allows. But on the lab side of the building, in those buildings, you want to be able to keep those air handling units and exhaust fans running to maintain the containment for fume hoods or other containment devices, so that when your folks come in the morning, it's a safe place to work. So they're typically 2 different systems, or systems that have modular ways of scaling things on and off, or turning them up or down in terms of capacity. But for single story, we typically separate them completely.
So just keeping everything decentralized.
Yeah, two different air handling streams and 2 different. Now you can what we do talk about flexibility and adaptability. If you had a 50-50 floor to floor, we may say size them both for 60%. So if you reduce the lab space to 40% and the office goes to 60, that air handling unit can support that larger office space. If it goes the other way, your lab air handling unit has a little more capacity to make it a 60% lab building versus a 40% lab building. So that flexibility and adaptability criteria I talked about at the very beginning is important to allow you to, because if you're going to pre-invest in that air handling unit and get it on the roof before you have a tenant, you don't want to be painted into a corner. You want to have that flexibility to react to the market and the possible tenants that are going to move in.
Thank you.
Good. I think there was a question about the UPC code. I think we'll reach out to you and get whatever information you need. And I think that we'll do it that way. Okay, Ray, I think we've hit our limit. We appreciate everyone's time. Thank you, Ray, once again, for being clear about certain things that in a hot market that there's so many questions out in the marketplace about.
I'm happy to support any of those questions as well moving forward.
Okay, thank you, everybody.